In today's lesson, we are looking at polynomial graphs. We are going to use technology to help graph them, Desmos or graphing calculator, but we are also going to talk about all the information we know without using technology. So technology for the final graph, but what information do we know without using technology? So for the graphs, I have them in 4 different categories, and the categories are based on a leading term. So ax to the power of n, and then the rest of the polynomial. This is just the leading term. So we're going to look at when n is even for both of these. So even exponents. And then when a, the leading term, is positive versus negative. So for starters, when n is even, but a is positive, that is telling me information about my end behavior. My end behavior will go towards infinity, towards positive infinity. My y values will go towards positive infinity in both directions. So in between, it could be doing lots of things, but the end behavior is doing this, going the same direction. And then on the other side, when n is even, but a is negative, so if that leading term has a negative coefficient, the end behavior will be going towards negative infinity. So in between, it could be doing lots of things, but the end behavior, the leading term tells you about the end behavior. So the first function is f of x equals 3x to the 4th minus 5x squared minus 1. Before even looking at the graph, I could write the end behavior as x approaches infinity, y will approach infinity. As x approaches negative infinity, y will approach positive infinity. Now, the other thing I'm going to look at is specifically this exponent. Not that it's even, but that it's the number 4. What I did down here is just sketch, this is just like a pretend x-axis. And we're just going to talk about possibilities, not guarantees, but possibilities. So for this function, I know the end behavior is doing this. So in between, if the exponent is 4, my graph could cross the x-axis a maximum of 4 times. So it could go, there it crosses once, twice, 3, 4 times. 1, 2, 3, 4. Now, it does not have to cross 4 times. It just can cross a maximum of 4 times. It could cross less than 4 times. So a maximum of 4 zeros, and then the other thing is turning points. So whenever it changes from like decreasing to increasing, increasing to decreasing, these are turning points. Because the exponent was 4, I'll have a maximum of 3 turning points. I could have less, but I just can't have more. Now, before I actually finish graphing this, I'm just going to talk about another function here. So it still has an even exponent. This time it has a negative leading coefficient. So just looking at the leading term, and now I know the end behavior. As x approaches infinity, y is approaching negative infinity. And as x approaches negative infinity, y approaches negative infinity. So even exponents, they always approach the same. Positive, positive infinity. Negative here, they approach negative infinity. Okay, so I know the end behavior will be doing this. But now the exponent of 6, that's what's going to tell you what it could be doing in between that end behavior. It could cross the x-axis 1, 2, 3, 4, 5, 6 times. 1, 2, 3, 4, 5, 6. It could cross less than 6. It cannot cross more than 6. And then if you count the turning points, 1, 2, 3, 4, 5. It's always one less than your exponent or your turning points. And that is maximum number of turning points. Now I'm using technology. I'm going to sketch these graphs, and we'll talk more about how to do this in class. What I marked on the graphs are each unit is going to count by 0.5. It'll just help me draw these graphs a little bit better. So the first one, I'm just going to get some key points, and I'm totally just estimating. I'm going to put that it crosses here and here, and then I have some turning points. Totally just estimating. It's going to do this, 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 and this. We'll talk about in class about getting a little bit more exact. So look at these. It only crosses twice. So that means that's fine. It can cross up to 4, but it only crossed twice. So it can cross less. And then this has 1, 2, 3 turning points. And for the next one, once again, I'm just putting some kind of key points on here, just estimating these graphs. It's going to go up, down, up, down. So what we said was it could cross a maximum of 6 times, but in this case it only crosses 3 times. And then turning points, there's 1, 2, there's 3 turning points. It could have had up to 5, but it only has 3. Okay, now we're changing things to odd exponents. And once again, starting with that idea of end behavior. When you have an odd exponent, but the leading coefficient is positive, here's what your end behavior will do. And then it can do all kinds of stuff in between, but here is your end behavior. And on this other example, if a is negative, this flips. So end behavior does this. And then it might do lots of stuff in between, but here is the end behavior. All right, so here I have another polynomial. The leading coefficient is positive and the exponent is odd. So we can go straight into writing what our end behavior is. As x approaches positive infinity, y approaches positive infinity. As x approaches negative infinity, y will approach negative infinity. The y values will be approaching opposite directions. And then because it's exponent 3, if I get my end behavior on here, that means that it could cross the x-axis a maximum of 3 times. 1, 2, 3. 1, 2, 3. It doesn't have to cross 3 times, but it can cross a maximum of 3 times. And then here are my turning points, 1, 2. And then here's another polynomial. It's still an odd exponent, but a negative leading coefficient. So now if we want to answer end behavior, as x goes to infinity, y goes to negative infinity. And as x goes to negative infinity, y goes to positive infinity. So if I'm doing a sketch, because it's exponent 5, here's my end behavior. It could cross the x-axis a maximum of 5 times. 1, 2, 3, 4, 5. Could cross less, can't cross more. And then how many turning points? 1, 2, 3, 4. So now I'm using technology to just sketch a graph. Again, on the x-axis, each unit is going to be 0.5. I'm just going to get some key points and do a sketch here. So for this one, it does something kind of like this. So it only crosses twice. And for the last one, it's kind of real tight in here, and then it goes down and up. So this one crosses 3 times. It could have crossed a maximum of 5, but in this case it crosses 3. So now I'm just ending the video. Here are 2 polynomials, and we are going to, without graphing, without using technology, answer these questions. And you can answer all of these questions using the leading term test. You're just looking at the leading term of your polynomial. You're looking at your a value and your exponent. So in the first example, I have 7, so that's odd, and then I have a negative a value. So just by looking at that, we're going to describe the end behavior. So odd exponents, end behavior, are in opposite directions, and because it's negative, it's going to do this. These are the end points. So as x approaches positive infinity, y approaches negative infinity. And as x approaches, that's supposed to say negative infinity, y will approach positive infinity. So answering that just by looking here. And then at most, how many real zeros? Exponent 7 means there will be a maximum of 7 real zeros. And then at how many turning points? Turning points are always 1 less than your exponent. So this has a maximum of 1 less, 6 turning points, and I'm going to be lazy and just write TP. Okay, last example. This time, exponent is 4, that's even. Leading coefficient is positive. So I know the end behavior, because it's even, it's going in the same direction. Because it's positive, the end behavior will be going up in both directions. So as x approaches infinity, y approaches infinity. As x approaches negative infinity, y also approaches infinity. And then because the exponent is 4, there's a maximum of 4 real zeros. And then 1 less than 4, 3, there's a maximum of 3 turning points on my graph. So there's your full video on polynomial graphs. Good luck with your lesson.